This is question number 9 from the third probability and stats revision quiz, and it's a relatively simple one to do, not that easy one to understand, and basically we've got a multivariate set of data here that we've been given with n equals 25, and we've been given the result of a multiple regression where we've got some estimate for y based on these betas and x's is what we're trying to show, and we're trying to find this hypothesis, or test the null hypothesis that beta 1 is equal to 0 against an alternate hypothesis that it is not equal to 0, and then we're using these little b's to be the notation for the relevant partial slope of the fitted least squares regression surface, and the standard SE B1 is going to be the standard error of B1. And then assuming that our assumptions are all of the regression are satisfied, which of the following is the distribution of the test statistic little b minus 0 divided by the standard error of B1? So what does that even mean? So basically what we're trying to do is to come up with an estimate for y based on these variables. And if we were able to come up with the exact best possible fit for the beta values, that and my daughter just joining in, if we could get the best value possible for these beta values, then we would get an estimate for y with some error tagged on the end, and you can see the notes for that. But when we actually try and come up using the least squares method to try and work out what the best value for these betas are, we actually don't get what the best beta would be either, because we don't have enough. We don't have an infinite set of data in order to generate the prediction. So the actual prediction that we come up with, we're not actually predicting y, we're predicting y hat, and the difference being that that's predicted using our predicted variables, not the best possible, absolutely perfect if you had every set of data variables. So our y hat's going to be equal to b1 plus little b0 plus little b1 times x1, etc. And so these little b's each have their own distribution, and it turns out that distribution has a number of degrees of freedom. So it's going to be a t distribution, and the number of degrees of freedom is actually equal to our n minus the number of variables, including the intercept. So it's pretty straightforward to actually calculate, because all you do is you take that number of data points, 25, and take away the number of betas you've got, including the intercept. So 1, 2, 3, 4. 25 take 4 is 21. So we've got 21 degrees of freedom, and it's a t distribution, as you can see here. So it's not that easy to get your head around, and if we had more time, I would say go and read the notes. But in the meanwhile, I would suggest just remembering that in order to come up with these distributions for little b's, it's always equal to the number of points that you've been given, or what is n equal to, minus the number of beta values, including the intercept. So if you use three independent variables, it will always be minus 4, because there's an intercept as well.